Welcome back, everyone. I'm Kara with the Ohio LTAP Center at ODOT, and I'll be your host again today. We are moving into part two of our series on designing pedestrian facilities for accessibility, and we're very happy to have Ron Eck back with us. Just a few quick reminders to help you get the most out of today. If you have questions for Ron, please drop them in the questions panel. We'll be monitoring those throughout the session and address them as we go or during our Q&A at the end. For any tech issues, just use the chat panel and our team will jump in to help. Also, keep in mind, we are recording this session. You'll get a link to the video afterward, as well as a link to the PDF handout. If you want to follow along with the slides, you can also grab the PDF handout right now in the handouts pane. With that, let's get into it. Ron, the virtual floor is yours.
Thanks, Kara. I hope you're hearing me okay this morning. It's nice not to have to use my phone like I did yesterday. But welcome back, everyone, to day two. Yesterday, we talked a little bit about introduction to some of the laws and requirements. We looked at the pedestrian environment. We talked about some of the characteristics of pedestrians with disabilities. And then we introduced the PAR. We talked about width and cross slope and gradient. And I think that's where we stopped. I understand we had some questions, so we'll start off by asking or going over those questions, but also if, since yesterday, now that you've had time to think about this, if questions have come up, other questions, feel free to put those into the chat. So Kara, I'll turn it back to you to go over the questions that came in yesterday.
Wonderful, thank you, Ron. Okay, so this question came in closer to the beginning of yesterday's webinar. And this person said that all the videos that were shown regarding accessibility issues were during construction. And they were wondering if guidelines have been provided on how to design access, or is it up to the contractor or local government entity to be creative?
Great question. And actually there is guidance with respect to work zones or temporary traffic control. One, of course, is PROAG. PROAG requires the alternate access route. I think I used that term yesterday. If a sidewalk is detoured or narrowed or that sort of thing. So PROAG is one requirement. The other requirements are contained in Part 6 of the Manual on Uniform Traffic Control Devices, the 11th edition, which was issued in 2023, contains a lot of good material about accommodating disabled pedestrians in work areas. And in fact, a resource that's available in mid-January for Ohio LTAP, I presented a 3-hour session. It was two 1.5-hour sessions, 2-part session on ADA and work zones. And Kara can correct me, but I believe that's been recorded, and I think it's available on Ohio LTAP's e-learning site. So that's feel free to review and go over that material at your leisure for anyone wanting more details about ADA and work zones.
Wonderful, thank you. Question 2. Do utility pole down guys located in sidewalks need to meet the protruding objects requirement? Does it matter if the down guys are parallel versus perpendicular with the direction of the sidewalk?
Great question. And yes, the guy wires, I'll call them, or the down guys associated with utility poles should comply with the in Chapter 4 of PROAG, the protruding object requirements. And it's too bad in many of the other ADA classes I teach, I have a photo of some guy wires which are protruding object hazards over a sidewalk. Maybe I'll insert that for class tomorrow. But yes, those guy wires can be a particular protruding object issue. So we do need to be alert and attentive to those and make sure they comply with the protruding object requirements. Good question.
Wonderful, thank you. Okay, and our third and final question that we did not get to yesterday was, does cross-slope apply in crosswalk sections?
Another good question. Yes, the cross slope requirements do apply, but there are some other factors that enter in, and actually we'll talk about that today. And if whoever asked that question, if you still have questions after today, please put it in the chat or speak up. But we will talk about cross slope requirements for crosswalks in today's session. Did any other questions come in, Kara, this morning?
Wonderful. Well, we had, and I believe this question was a follow-up to the question from yesterday. We did have a new question come in, and he's asking if you have any examples of where the street surface within the crosswalk meets ADA and PROAG as far as cross slope. But I think you were saying that you were going to touch on that today.
Yes, we will talk about that
Okay.
today.
Wonderful.
I'm trying to think whether I have photos of a compliance situation, but yet we will talk about the requirements today. I may not have a photo, but we will talk about those requirements.
Wonderful. Well, then that gets us all squared away with any questions from yesterday or first thing this morning. So I believe we're ready to move on with part 2.
Okay, great. Thanks, Kara.
My pleasure.
So let's get started. I believe this is where we ended. We didn't talk about this slide yesterday. I think time ran out. But we were talking about cross slope. We were talking about gradient. And one area where cross slope comes into play is at driveways, because this is a cartoon type depiction here. But notice the driveway has a steep grade to the driveway, and that becomes a cross slope to someone crossing that driveway on foot or using a mobility device. So that's a steep cross slope. But the other complication that happens at driveways are the grade breaks, or these flares where the sidewalk crosses the driveway. And I realize this is a cartoon depiction, but it is technically accurate. And if you look closely here where my cursor is, the small front wheel of the wheelchair is off the ground. And that is not a good situation. Anytime one or more wheels of a manual wheelchair leaves the ground, the stability of the wheelchair is jeopardized. The chair could tip over or flip over, and so it's not a good thing. And you'll see this in the next video here, probably in the next hour or so this morning. So our designs, whether it's a driveway or anywhere, should be such that all 4 wheels of a manual wheelchair are always on the ground. So keep that in mind. But as you see here at this driveway, that's not the case. And you'll see it in an example in the video as well. This looks like a West Virginia driveway here, or Southeast Ohio driveway, 9.1% gradient on the driveway. So a 9.1% cross slope for someone crossing, using the sidewalk to cross the driveway. And that's not good. It makes it difficult to maneuver. In fact, people with balance issues or certain types of assistive devices could actually sort of tip over, which is not safe and not good. So how do we address, coming up with solutions for sidewalks at driveways? And here is my list in the second bullet. This is Ron's list of factors to consider when you're choosing or designing an accessible driveway. We need to consider the sidewalk width, of course, minimum 4 feet, 5 feet would be desirable. The planter strip width that you see here, or the buffer zone or tree lawn, a lot of different names for that area. But I mentioned yesterday, these are not required under PROAG, but I think you can see here that having that buffer strip or planter strip can be a benefit, because notice here, they were able to steepen the driveway within that buffer strip. Another factor is the curb height. Obviously, available right-of-way is a factor. And then, of course, we need to consider the design vehicle that uses the driveway. So let's look at this driveway crossing. And actually, this is an accessible driveway. It looks like it's a 5-foot sidewalk, 2% cross slope, nice, firm, stable, slip-resistant surface. So it looks like it complies with PROAG. We can't see what the land use is here on the right. I think it's some sort of like a small medical clinic. But let's say it is a small medical clinic. Probably the traffic that it generates would be passenger cars, pickup trucks, SUVs, what maybe like a FedEx or UPS box delivery truck or something like that. And it seems to me that those vehicles can probably get over these grade breaks with no problem. But let's imagine this land use that we can't see here. Let's imagine it's a convenience store or something like that. And you all are probably familiar with these trucks that deliver beverages, soft drink and beer to convenience stores or restaurants. They're semi-trailer units, and they're kind of low ground clearance and long wheelbase. And so those vehicles may drag or high center or actually get stuck here. So that those vehicles might not be able to access this driveway design. So that's why we have to think about the design vehicle and balance all of these factors. We could make a compliant sidewalk that vehicles that need to access that business or land use could not make it, could not be able to access it. And that's not what ADA wants. We don't want to affect the livelihood of businesses, put them out of business because people can't access the land use. So we have to balance accessibility to the land use with the ADA requirements. And so driveways are an area where technical infeasibility, which we talked about yesterday, technical infeasibility may come into play. Just another thing to consider, you remember I yesterday mentioned how PROAG is an accessibility guideline. It's up to us to build safety into these locations and projects. Notice it looks like this driveway from the arrow here on the pavement, it looks like this is one way in. And so in that case, I think this driveway looks okay. But imagine this was a two-way driveway. Drivers could exit here and also enter here. Would you agree with me, for an exiting driver, this large shrub makes it difficult for them to see an approaching pedestrian? So if this was a two-way driveway, my advice would be to get rid of that shrub to make sure we have good sight lines so drivers can see pedestrians and pedestrians can see approaching vehicles. Here are a variety of possible solutions for the driveway challenge or issue. Again, what works best is going to depend on your specific context or situation. You know, if you can do it, put a flat, uninterrupted sidewalk like you see here. Notice the driveway was steepened in the planter strip, also steepened here, but we have a 2% cross slope across the driveway using the sidewalk. I'm not sure what happened here. Someone sent me this, so I don't know the details, but notice this driveway, 7% grade, extended all the way across the sidewalk. And so that's a 7% cross slope on the sidewalk, which is not accessible. So this is a non-compliant sidewalk section now, but it looks kind of brand new. And to me, it shouldn't have been allowed to be constructed like that in the first place. And what's troubling to me is I'm not sure what that driveway is serving. Maybe a couple parking spaces here, but again, that could have been done better, I think. This is Morgantown, West Virginia. Again, same project I mentioned yesterday. This is the arterial street where for about 3 blocks or so on both sides of the street, the court ordered that the West Virginia DOT make the cross slope compliant. And for context, there's a sign bridge. You may remember I showed you yesterday the supports for a sign bridge that were in the middle of the existing sidewalk, and the DOT widened the sidewalk around the sign bridge. That's where that was. So this location is on the same block as what I showed you yesterday. And here, before this project, the grade of this driveway came all the way to the street. So the cross slope on the sidewalk there was about 7 or 8%. And so as you can see, as part of this project, now this is a 2% cross slope, but this area has been steepened considerably and quite a grade break here. This is a kind of a medium rise residential facility. This is not the main entrance. This is sort of a pickup and drop off. And so really all the vehicles that are using this would be pickup trucks, SUVs, passenger car automobiles. And so I think they can probably navigate that grade break okay, but a commercial type vehicle may not be able to, but the commercial access is in the rear of the building. Maybe put a level route at the back of a wide sidewalk if you can do it, if you have a wide sidewalk. So notice here, this would be the par, this strip where the arrow is. The pedestrian circulation route is from the back of curb to the back of sidewalk. So in this case, the par is contained within the pedestrian circulation path. So with this accessible route available, the pedestrians with mobility assisted devices don't have to cross the grade breaks at the driveway or negotiate the slope, the cross slope at the driveway. Here's another example. This is kind of top of the line. It's nicely landscaped and things to direct pedestrians away from the flares and the cross slope at the driveway. Another approach, use a mountable curb. I mentioned yesterday, mountable curbs generally are frowned upon in ADA activities, but here's a case where I think this mountable curb probably works well for this driveway. And so, as I think I mentioned, I like to say never when it comes to ADA, because we again have to design for the specific context. And in some cases, this design that we would not normally recommend may be most appropriate for a specific location. Or I think I have one more design, would be to lower the sidewalk. Notice here we're ramping the sidewalk down, level area here, 2% cross slope, and we've steepened the grade of the driveway here. Or here's a photo version of a similar situation. So you can see a variety of different ways. Think about what might work best for your particular situation. The PAR also addresses surfaces. And you can see there's kind of subtopics under surfaces, including grade breaks and changes in level and openings in the surface. PROAG is pretty generic when it comes to surfaces. It says they must be firm, stable, and slip resistant. In my opinion, the best practice is they should be smooth. But the key thing is firm, stable, and slip resistant. So concrete, asphalt, those would be accessible surfaces. Steel, like a steel bridge over something in the sidewalk maybe, that would certainly be firm and stable, probably not slip resistant when it's wet, so we may want to do something in the way of texturing to provide some slip resistance when wet. Same thing with wood. A wooden boardwalk arrangement would be firm and stable, but again, may not be slip resistant when wet. So we may need to do something to provide slip resistance to the surface. But surfaces like grass, I think we talked about that yesterday. Grass is not an accessible surface. Bare earth, a mulch surface, stone, those are not accessible surfaces because they are not continuously firm and stable. You know, I guess now maybe a grass surface here in Morgantown for the last 2 weeks might be firm and stable because the ground is frozen so solid. But you know, come the warm up that will certainly come, that ice is going to melt, soil is going to kind of become muddy, and so it's definitely not going to be a firm and stable surface all the time.
Ron, we
Yes,
have a couple of questions for you.
sure.
First question is, what running slope of drives should be the max?
Running slope of driveway should be the maximum.
Um, I'm not, it's the way it's written, it says what running slope of drives should be the max. So I'm not really sure.
I'm assuming that means across the sidewalk, which would be the cross slope of the sidewalk. That's a good question, and not to try to evade the question, but the answer really is it depends. This is an area where probably technical infeasibility will apply. You want to try to flatten the driveway where it crosses the sidewalk a little bit to reduce the cross slope at the sidewalk. But we also have to recognize that the driveway has to allow, as I said earlier, has to allow vehicles of certain types to enter and leave and use the driveway. So you have to sort of balance those two things. And remember, the obligation is make it accessible to the maximum extent practicable, and then document a technical infeasibility. Show what options you looked at, show how it's accessible to automobiles or vehicles, and also how you tried to make it accessible for pedestrians, especially pedestrians with mobility assistive devices. But those are, I wish I had a better answer, but the driveways like that can be a real challenge, especially in where you have significant elevation differences like we do here in West Virginia or southeastern Ohio or other parts of the country. Just make it accessible to the extent practicable to do so, and then document everything.
That sounds like a great answer, Ron. Okay. Let's see here. And our other question, how would you approach sidewalks being installed through driveways that have existing grades over 15%?
I'd probably give the same sort of answer I gave to the previous question. Kind of do the best you can, balancing both users, and document that you made it accessible to the extent practicable to do so, given the various constraints that you had at those driveway locations. But as I said before, those driveways can be a real challenge when it comes to ADA.
Okay, well, thank you, sir. That is all the questions we have for now.
Okay, thanks.
Mhm.
Thank you all for the good questions as well. Keep them coming if questions occur to you. Grade breaks. ProAg requires grade breaks shall be flush, and notice at this curb ramp, there's a lot of different grade breaks. They all need to be flush. The final rule calls this, the ProAg final rule calls this a change in level. Notice it's a heaved up sidewalk slab. I think we talked about this yesterday. I'm sure many of you face this issue in your community. I know we do here in Morgantown. This is what I call a double whammy for municipalities. And the reason I say that is this heaved up sidewalk slab, for a pedestrian walking in the direction we're looking, an able-bodied pedestrian can trip and fall on that. And maybe if it's a senior citizen, maybe they fracture a hip and they're seriously injured, and they may file a tort claim, a lawsuit against the municipality seeking compensation for their injuries. So that's one type of legal exposure. The second type, which is why I call it a double whammy, is that this is also an inaccessible section of sidewalk because of that elevation difference. So someone in a wheelchair, someone in a walker may not be able to negotiate that section of sidewalk and reach their destination. Maybe they're headed to the grocery store down the street and they can't get there because now the sidewalk is has an obstacle or a barrier there. And so that individual could file an ADA civil rights claim, alleging they can't access destinations that they need to access. So that's why there's two different legal liability exposures. One is a tort claim if someone's injured. The other is a civil rights claim, an ADA claim, if someone can't access the destination that they wish to reach.
So Ron, we have a question
Sure.
from someone who is asking who would get sued in that situation.
In this case, certainly well, again, it depends on how things are set up. And someone yesterday mentioned, in many communities, the sidewalks are the responsibility of the property owner. My experience has been in the tort claim cases where someone's injured and seeking compensation. In those cases, both the property owner and probably the municipality would both be defendants, both be sued. If this was an ADA claim because someone couldn't reach their store or reach their destination, that suit or that claim would be against the municipality because it's in the public right of way, and the municipality probably has the ordinance about sidewalk maintenance, and it could be argued they failed to maintain that ordinance because the property owner let the sidewalk reach this condition. So in the first case, an injury case, the attorneys are seeking, and you all probably heard this term, I used it in the tort class we did last week. Maybe some of you attended that. But in those injury cases, the attorneys are seeking the quote deep pocket, who has the most resources. In the civil rights lawsuit, the plaintiff just wants the barrier removed. And so in that case, the defendant would be the public entity, the municipality. Good question.
Great, thank you, and wonderful answer. Appreciate that. That was our last question for now.
Okay, thanks, Kara.
Mm-hmm.
So I mentioned these are tripping hazards. They're also barriers. I think this slide kind of shows that. How about this? I bet this looked great when it was brand new, but now over time and weathering and freeze thaw and tree root growth, I would argue this is neither safe nor accessible, and not a good situation in my opinion. In fact, if you look closely, you can almost trace the network of tree roots underneath this walkway. So we kind of were talking about changes in level, as PROAG calls them. What does PROAG say about changes in level? And here's what they say, and actually ADAG says the same thing. So both PROAG and ADAG are identical in terms of these requirements. They say vertical surface discontinuities shall not exceed a 1/4 inch maximum. So think about that. That's not very much. Those elevation differences or discontinuities between a 1/4 and a 1/2 inch shall be beveled with a slope not steeper than 50% and beveled across the entire vertical surface discontinuity. So that's shown here on the right, a 2-to-1, 2 horizontal to 1 vertical, or a 50% kind of beveling or ramping. And that can be done by putting in a wedge of concrete here, or maybe by grinding down the higher elevation to create that ramped condition. So in the earlier slide, when I talked about grade breaks and said they must be flush, that basically means they must be less than a 1/4 inch maximum. How about this one? This is in Virginia. Notice the before and the after. The before is certainly, I would say, both a safety issue and an accessibility issue. How about the after? To me, that does not comply with the PROAG requirements. That's not an accessible sidewalk. But this is one of those challenges. And this is where kind of the answer is it depends. As I've been told, this is a historic city in Virginia. I've been told this wall is historic, so it can't be touched. It's on the historic register. The tree apparently is 300 to 400 years old. It's also historic. It's a lot of communities in the East sometimes say the kind of the joke that George Washington slept under this tree. Well, it might be in Virginia, maybe somebody famous did sleep under this tree. So this tree can't be touched either. And so, and of course, I think you all realize if we remove these slabs and start hacking away at the tree roots, we jeopardize the health of the tree, and that make that all that damage to the tree roots may cause the tree to die. So we can't really do that either. What to do about it kind of depends. I mean, I've seen cities in the South where they have the, I guess they call them live oak trees, which are very large and may actually intrude on the sidewalk, but they will build wooden ramps and a boardwalk maybe over this area and then ramp back down to the sidewalks. I mean, that's considerable expense, both initial cost and maintenance expense, but that might be one way to make this accessible without interfering with the various constraints that we see in this image. Another possibility, and we'd have to look at it from a broader perspective, but, and maybe not the most desirable solution, but PROAG does not require an accessible route on both sides of a street. It would be desirable, but not required. What we could do is look at the other side of the street, which we don't see really at all here. And my guess is the other side of the street's probably going to be a similar situation. But if the other side of the street maybe doesn't have trees, maybe is more accessible, what you might do is designate the other side of the street that we don't see here as the accessible route and just leave this maybe in this condition that we see here. So again, the answer is really going to depend on the situation. And here we can't see the other side of the street, so we can't really do a detailed assessment. But I think in some cases, we may need to think beyond just the section of sidewalk we're interested in. We may need to look at what's happening across the street as well. Here's an example of, in the left, putting that wedge of concrete to create the ramp. Shows the concept. My concern is I think that's too steep. I think that's steeper than 2 to 1 or 50%. So I think that should be redesigned. This slope down here on the asphalt looks okay, but I hope this is just temporary because it looks like the asphalt is kind of deteriorating. But at least from a slope standpoint, it looks okay. Another issue sometimes, especially in older communities, is utility covers in the sidewalk or in the PAR. Notice here, upper left, I'd argue that's both a safety issue, but also a barrier for someone in a wheelchair or using certain assistive devices. Desirably, things should be flush and textured if there's a slip resistance issue. Automatic metering infrastructure. Not clear if that meets the PROAG requirements or not. Rough textures. I know a lot of designers like rough textures from an aesthetic standpoint, but rough textures from an accessibility standpoint can cause tripping hazards, like the brick that you see here in the right. It can cause confusion to people who are blind and using the cane or using their feet in terms of detecting tactile cues. Also, and maybe this should be at the top of the list, people with certain types of spinal cord injuries who are in wheelchairs, vibration can be excruciatingly painful. So that's another reason for providing a smooth surface, so as not to create or not cause pain for individuals in wheelchairs. And those of you in public works, maybe in the operational side of things, I think you probably appreciate that some of these surfaces can create some maintenance difficulties, especially, for example, trying to keep a brick or paver block surface like this, keep it in good, safe condition, can require considerable maintenance. So I'm a fan.
Another question.
Sure.
So the question is, if one side of the street is designated as the dedicated PAR, what is the best way to communicate this with to facility users?
Great question. And yeah, there's really no clear guidance in PROAG. I have seen a few cases, and I should have gotten some photographs, but I have seen a few cases where the municipality has used maybe small signs to indicate the accessible route, or to maybe indicate with an arrows and message or something that pedestrians need to cross the street to access the accessible route. Other communities I've seen don't really do anything. And if you allow me to back up here, I apologize, back up to this slide, and maybe would rely on, say, someone in a wheelchair, which this is probably most impactful, to let them sort of recognize that, and that this would be a difficult path, and then use the other side of the street. I probably would prefer some type of signing, but there is no standard signing that I'm aware of for that purpose. But I think signing would be helpful to direct pedestrians to the PAR, we'll call it, as you said, the PAR side of the street.
Thank you, Ron. That was all we had for now.
Okay, thanks, Kara.
Mm-hmm.
I'm a fan of the designs you see here. Remember, I said smooth is best in terms of reducing pain for wheelchair users, people in wheelchairs. So I like these designs here. Notice here that the travel path is smooth, hard concrete, and then the buffer or the border or the planter strip and the frontage zone here looks like that's stamped concrete, but the color and texture are in the border areas. Same thing here below. This is next to a college campus, so aesthetics is important. But notice the actual travel path is smooth concrete, and then the texturing and the color, which in this case is actual brick, I believe. Notice that that's in the border areas. And so that's my recommendation for terms of good design for a walkway in terms of surface condition. You get the benefits of both the aesthetics and the accessibility, but I think it makes a much better situation for users with mobility impairments. I mentioned horizontal openings like grates and joints, and here you see some of the issues. Notice in the left here, the small front wheel of that wheelchair drops into that grate opening. The wheelchair is going to stop suddenly, and at best they're going to be stuck there probably, unless somebody comes along to help get them out. But at worst, depending on the speed of the chair, the person in the wheelchair, when it comes to an abrupt stop, the person in the chair could actually be pitched forward onto the sidewalk and suffer some serious injury. So we need to pay attention to openings, horizontal openings in the PAR. Here we see a grate. Looks like neither of these grates comply with PROAG. Notice PROAG says openings shall not permit passage of a sphere more than 1/2 inch in diameter. And here I think everyone would agree with me. Maybe someone's using a cane or crutches. I don't think the cane tip or crutch tip is going to drop into that opening, but it's going to, I think you'd agree, it's going to affect the bearing of it. It's not going to be solid bearing, and so it's going to affect kind of the stability and balance of the person using the cane or the crutches. Tree grates, I think if you remember, we saw this in the video yesterday with Kathy. I think the grates that were in the video were the older style. They were bare metal. They had large openings. In fact, her walker tip, I think, almost maybe dropped into one of those openings. So desirably, tree grates should be in the border areas or furniture zone, not in the PAR. But I realize sometimes they will be in the PAR. In that case, it's important to use accessible grates like this one. Notice this has very small openings that comply with PROAG. And if we look closely, we would see that it also has some texturing to provide slip resistance. One question that comes up sometimes is, how do I end a sidewalk? Like, notice this upper left here. Notice the sidewalk comes right up to the curb, but then there's a sign, crosswalk closed. This is probably for safety reasons. The municipality or the state DOT, whosever roadway it is, probably decided they don't want pedestrians crossing here, given the traffic flow, traffic volumes, traffic speed, turning movements. And so hopefully there's an accessible route on the other side off the image here. But they've and again, you don't have to have all 4 crosswalks being accessible. As long as the intersection's accessible, that's fine. You're still complying with PROAG. So for safety reasons, apparently this agency has said we don't want pedestrians crossing here. But think about it. An able-bodied pedestrian or a sighted pedestrian can see this sign and hopefully will comply with it and find another route, like maybe crossing down here. But think about a blind pedestrian using the cane. They will detect the curb here, and they know, they've been taught in their orientation and mobility training, they've been taught that when they reach that, detect that curb, that means they're about to cross the street. And they are taught that they need to listen for traffic sounds or listen for the accessible pedestrian signal to determine when it's safe to cross. But having said that, there's nothing here that tells a blind pedestrian they are not to cross here. All the curb tells them is they're about to enter the street. And remember, a blind pedestrian can't see the sign. So how do we close a sidewalk where we don't want pedestrians crossing that will also send a message to the visually impaired? And the way to do that is, and PROAG calls for at least a 2-foot strip of detectable surface. So we could use grass or landscaping or something like that. We could put in a 2-foot strip of detectable surface. So notice in this one on the right here, pedestrians walking, we'll call it north toward the top of the picture, they can detect that grass under their cane tip. It feels different than the concrete sidewalk they were on, and so they know they can the sidewalk no longer continues to the north because there's this offset intersection. And so they would either go to the left, to their left, or to their right, or to their right. There's a curb ramp here to continue on their way. And hopefully there is a crossing nearby. But notice at these offset intersections can be really tricky for pedestrians. So this agency, it looks like, has determined they don't want pedestrians crossing the road that runs diagonally here, but there should be some crossing opportunities somewhere close by. So I did want to mention that because that question comes up sometimes. When you end a sidewalk, you can't just end it at the street like this, because that doesn't convey a message to the visually impaired that the sidewalk is closed. We have to have, I guess one other thing you could use, I'm not a fan of it here, is you could put a railing of some sort or barrier around here. But my issue with that is likely semi trucks and traffic would damage that or tear it out. So the best thing would be to put in a 2-foot strip of grass or landscaped surface here between the end of the sidewalk and the curb. I did want to say a few words about quality control as well. And we need to make sure that in terms of inspection, that we do actual measuring. I talk to some people sometime, especially contractors, who might say, I've been doing it for 30 years. I know what I'm doing. But the truth is they've been doing it wrong for 30 years and no one ever called them out on it. So we need to rely on measurements. Don't rely on kind of eyeballing it or the visual inspection. And make sure carpenters and the concrete crews and finishers and inspectors are trained and understand what sort of product we're looking for. And here you see a couple, I guess these are inspectors. which is a good thing, but I have a couple comments about, or one comment about each of these. Notice here on the left, this fellow is using the digital level to measure apparently the flare on the curb ramp, but it appears he's measuring it incorrectly. As we'll talk about in a few minutes here, the correct way to measure a flare is it needs to be at the back of curb and parallel to the curb. So I'm not sure what he's measuring, but his level is not oriented properly if he's trying to measure the slope of the flare. And then this individual, I guess that's maybe a 6-inch level, or maybe it's his phone. I think it's a 6-inch level. And I use a 6-inch level, but I use a 6-inch level, for example, in the gutter pan or at the on top of curb to get the slope of the curb. To measure the grade of a ramp that may be 12 feet long, in my opinion, this is not the proper device. We should be using a 2-foot level to measure that grade. So make sure you're making your measurements correctly and make sure you're using the proper tools to make those measurements. And before we leave this topic, here's a little example. Notice here we have a driveway. Actually, I guess 2 driveways, but we're going to focus on the one in the foreground. And this is a medical clinic here that we see the parking lot for. But notice the grade of the driveway extends across the sidewalk. So that's a steep cross slope to the sidewalk. And if we look closely, we can see some grade breaks or flares here. Most likely that would cause the wheel of a manual wheelchair to leave the ground, which is not a good thing. So how might we redo this to make it accessible? And here is one idea, it's kind of photoshopped in here. Notice the sidewalk ramps down to this level area here. The sidewalk is level across the driveway and then ramps back up to the sidewalk. And the driveway grade here is steepened to 10%. For a medical clinic like this, again, I doubt that there's probably not semi trucks and big rigs coming in here. Probably automobiles and box delivery trucks probably can, I'm thinking, make that grade break so they can still access the facility. But remember, we do, and coming up with the driveway sidewalk design, we do have to consider what's the design vehicle using the driveway. So that brings us to almost to the end of the PAR, and then we're going to get into curb ramps. But what I would like to do at this point is show our next video, the second video in this series, which is depicting persons who use wheelchairs. And you're going to see 2 different types of wheelchairs. You'll see Marilyn, who uses a manual chair, and then you'll see Dennis Cannon, who's now retired from the access board, but he uses a power chair, and you'll be able to compare and contrast the 2. And I did want to mention too, I understand some of you may have had audio issues yesterday with the video. I apologize for that. But these videos are available on the access board website. If anybody's interested, you can download them or you can view them there. But these 4 videos are available on the access board website if anybody's interested in accessing them. So I think at this point, Kara, I'll turn it back to you to play this video.
Switching this back over to you, how they can find this video if they were not able to view it.
Yeah. Yeah, I hope you can hear me, Kara. The videos, all 4 that I'll show, we've seen 2 of them now, are available on the access board website. And they can be viewed there, or you can download them, whatever you'd like. And they're in the public domain, so they're available for use. Hopefully that was helpful. I think it did a good job of showing the issues faced by both types of chairs, but especially The manual chair, if you notice that some of those grade breaks, or she was trying to use the crosswalk to cross the street, it was a much steeper than 5% gradient. That it was, and she, as the video said, she works out, so she has good upper body strength, but she was really struggling, I think, at a lot of points. So using a manual chair in the built environment can be a kind of a very high exertion type of activity, and we need to keep that in mind in our work. So that wraps up kind of the PAR discussion yesterday and today. And if you have any questions about the PAR, feel free to put those in the chat. I would like now to move on to curb ramps. And of course, the curb ramps are important because they allow pedestrians to transition between the sidewalk and the street. And usually we find them at intersections, also at mid-block crossings, or where shared use paths or trails cross roadways. As we'll see tomorrow, they're also used at accessible on-street parking spaces, and they're also used at passenger loading zones and bus stops. They were first required back in '73, and as I said yesterday, they are considered the basic element of accessibility, so they really should be a top priority in our work, that we should have curb ramps to allow people to move between the sidewalk and the street, and the sidewalk. They do, though, present a conundrum, because remember, I just described a few minutes ago that curbs are a good thing for the visually impaired. As you see here in the schematic, notice my cursor here. This individual, blind individual using the cane, they can detect that curb, and that lets them know they have reached the end of the block, or they're about to enter the street. And so they will seek other information, mainly traffic noise or the sound of a traffic control device, to help them know when to cross. But for someone in a wheelchair, that curb is a barrier. They can't move between the sidewalk and the street. And so, of course, we install curb ramps, like you see here, to allow someone in a wheelchair or a walker to move between the sidewalk and the street. But if someone in the wheelchair, someone who's blind got lined up with the ramp, they could walk into the street without realizing it because the curb is missing. The curb is a cue for the visually impaired, but if that curb is missing, they might accidentally walk into the street. And so that's why we install the detectable warning, the truncated dome, detectable warning surfaces at the base of curb ramps. As the slide says, this is a replacement cue to indicate to blind and low vision pedestrians that they are about to enter the street. Here is a schematic view of a curb ramp. To orient you, the street would be down here running left to right. This is the sidewalk. So pedestrians would be walking left to right, right to left here. In the middle of the drawing is this large rectangle. This is the curb ramp. The grayish area here, these are the detectable warning surfaces at the base of the ramp. As we've talked about, there should be a level landing at the top of the ramp for turning onto and off of the ramp. And so it looks like this would be level, of course. So it looks like the PAR portion of this pedestrian circulation path would be towards the back of the sidewalk here. And then because this ramp is in the pedestrian circulation path, again, pedestrian circulation path, back of curb to back of sidewalk. PAR is this portion back here. But since this ramp is in the pedestrian circulation path, it needs to have flared sides, and we'll talk more about those. I mentioned that the ramps need to have detectable warning surfaces at the base of the ramp. That is to provide a visual. There needs to be color contrast, but also a tactile cue to the visually impaired that they are about to enter the street. And we'll talk more about detectable warning surfaces and how to use them. But let's look at kind of some curb ramp basics first, maybe before we get into the actual requirements. One is curb ramp alignment. Obviously, the curb ramp should be aligned with the crosswalks to help wheelchair users orient themselves to cross the street. And on small radius corners, like you see in both of these photos here, notice that it's relatively easy to have the curb ramps line up with the crosswalk. But on larger radius corners, it's not so easy, because one criterion for curb ramp is the curb ramp has to intersect the curb at right angles so that both wheels of the wheelchair enter and leave the ramp at the same time. So a curb ramp has to intersect the curb at right angles. But notice here, and this is a large radius corner compared to the previous slide, notice that to have the ramps be perpendicular to the curb, they don't exactly line up with the crosswalk they serve, but that's okay. That's just a function of geometry. Also in the photo below, this is not a single diagonal ramp. This is a ramp for this crosswalk. There's another ramp out of view on the bottom of the photo here. But again, notice this ramp is at right angles to the curb, which is the key thing, but it doesn't necessarily line up very well with the crosswalk. Curb ramp grade. Maximum allowed is 8.3% or 1 in 12 slope. But again, there's no allowance for construction tolerance. So what many municipalities do is they design the ramp grade for 7.5% so that when it's built, it won't exceed 8.3%. And when you're chasing grade, especially like in hilly terrain, the running slope length need not exceed 15 feet, but the slope must be uniform. And here's an example. This looks like Morgantown, but it's not. I'm not sure where this is. But notice here we have a new curb ramp, kind of steep, graded or sloped roadway here. And so this agency went 15 feet to intersect the existing sidewalk. That's what's meant by chasing grade. One other thing to note here, notice if you look closely, the detectable warning surface, and maybe in the gutter here a little bit, it looks like some sediment or debris accumulating. And it seems to me that that's originating from this cut slope here. So although it's not required by ProAg, I think here it would be a good practice to put a curb or little retaining wall back here to prevent that sediment and silt from washing onto the sidewalk there. To me, that would be a best practice. This complies with ProAg, it appears, but and that little curb or retaining wall is optional. But I think in this case, to me, that would be the best thing to do. Curb ramp length. Here's the formula for determining curb ramp length. You can see it's the curb height divided by the ramp slope minus the sidewalk cross slope. And in this case, you can see the ramp slope is 8.3, as we've talked about, 8.3%. The sidewalk cross slope, 2%. And let's assume we have a 6-inch high curb. If I plug into that formula, I come up with a curb ramp length of 95.24 inches, almost 96 inches, almost 8 feet. And then if you think about needing a 4-foot landing here from the back of sidewalk to the street, we're talking about 12 feet, 13 feet if you have a 5-foot landing. So as I think Dennis mentioned in the video we just saw, these ramps take up considerable space. You saw this illustrated very well, I think, in the video, the change of grade or counter slope. I'm not sure we saw this in the video, but what can also happen, what this slide is trying to show is, notice due to this kind of extreme change in grades here, that the footrests on the manual chair are bottoming out, and that could cause the chair to tip over. Here in the lower left, we're showing that sharp change of grade could cause the chair to actually flip over backwards. And I think you saw in the video the struggles that Marilyn had trying to negotiate. Even though her chair didn't tip over or bottom out, she still had to really struggle to negotiate that change of grade. So the final rule actually is different from the draft version in this respect, in that it provides an option for designers. They say where a change of grade occurs adjacent to curb ramps, the change of grade shall comply with A or B. And so they give designers an option. The A is the change of grade shall not exceed 13.3%. And of course, that's determined or calculated the 5% maximum cross slope of the street, or the 5% maximum grade for the crosswalk, and then the 8.3% max grade for the ramp itself, and that adds up to 13.3. Or if you can do it, option B says provide a 24-inch transitional space at the base of the ramp, and that's what we're showing here. And I realize you can't always do that. That's why they've made this an option. But if you can do it, this would be the best practice. Too bad we're not in person and can't go out like into a parking lot and demonstrate some of these things and allow you to actually traverse these geometries in a wheelchair. But I can tell you, this design where you put in this 2-foot level area here makes this a much easier change of grade to negotiate in a manual wheelchair. And I think we've talked about this. Without that flat area, the wheelchair can get stuck at the bottom of the ramp, or flip over, flip forward, or backward. So again, just as a reminder, because it is important, no more than a 1/4 inch vertical lip there at the base of the curb ramp. Curb ramp width. According to ProAg, the minimum width would be 4 feet. I think wider ramps are better. My recommendation is make the width of the ramp the full width of the crosswalk or the sidewalk. And actually, in ProAg, on shared use paths, ProAg requires that the curb ramp be equal to the width of the shared use path. So if you have a 10-foot wide, say, shared use path, then your curb ramp needs to be 10 feet wide.
Ron, we have a question.
Okay.
This person is asking, so is the grade max grade change between the this is a little hard to read. Sorry about this.
That's fine.
So is the grade max grade change is between the gutter and ramp, or ramp to asphalt?
It would be from the ramp to the gutter and the gutter pan and the cross slope of the street, both of which should be 5% or less. So it's that kind of the path that the manual wheelchair would take as it goes down the ramp and then enters the street. So the gutter pan would be included in that, and that max would be 5%.
Thank you.
Another thing to talk about when it comes to curb ramps, and we've mentioned this already briefly, are the landings. And ProAg says a minimum of 4-foot by 4-foot landing shall be provided at the top of a curb ramp and shall be permitted to overlap other landings and clear space. So here we see a level landing at the top of a curb ramp. And so the person would come up the ramp and do their turning on this level landing. Or likewise, someone on the sidewalk who wants to cross the street, they would come to the landing and turn onto the ramp and then cross the street. And this is a slight change too from the draft version of PROAG. The final rule says minimum 4 foot by 4 foot landing. And I'll introduce a couple terms here. One is unconstrained condition and the other is constrained condition. What we see here, notice that the grass is kind of flush with the concrete pad here, the landing. That's called an unconstrained condition. And so someone coming up the ramp in a manual wheelchair, their footrest can actually go out over the grass because it's unconstrained. And I don't know if you caught it in the video, it wasn't really highlighted, but at one scene, Marilyn came up the ramp onto the sidewalk, and then there was a curb with like a bed of flowers behind it, and Marilyn's footrest hit that curb. That's called a constrained condition. If there was a curb here or a storefront, that would be a constrained condition. And the best practice is if you have a constrained condition, and if you can do it, provide 5 feet, a 5-foot landing in the direction of travel. But under the final rule, the minimum is 4 by 4. I'm just sharing with you what the best practice would be for a constrained condition.
Ron, we have another question for you.
Okay.
This person says many standard drawings in Ohio call out the gutter cross slope as 1 by 12 or 8.33% or 1/12, sorry about that. Does this mean the ramp could only be 5% max?
Yeah, I mean, I'd want to see what you're talking about, but I'm not doubting what you're saying. I'd want to probably read that. But yeah, that would be my interpretation, yes. If your gutter pan is 8.3, then the maximum ramp grade would be 5%.
Okay, thank you, sir.
So here we see a ramp and notice, or here we see 2 ramps actually, and the landing. And notice in this case, the landing serves 2 ramps, which is fine. I would notice the ramps lack detectable warning surfaces, so that's not a good thing. That's not compliant. I think we looked at this photo yesterday, and I pointed out the difficulty in making this maneuver and the importance of having a level landing at the top of the ramp. And notice also without a landing, then a pedestrian using an assistive device, if they're not crossing the street, if they're just going around the corner, they experience the flares on 2 ramps, and they also experience the 8.3% grade, which is then a cross slope for the individuals using the sidewalk. But details are important. I'm not sure what happened here. Looks like a relatively new landing was installed, but there's a fire hydrant essentially in the middle of it, so it's not a functional landing. I don't know what happened here. Maybe the designer didn't go out to the site early on and see what was present there. Another thing to keep in mind is that there needs to be a clear space. The bottom of the ramp must have a 48-inch by 48-inch clear space entirely outside the parallel vehicle travel lane and within the crosswalk. And notice this diagonal ramp does not. And note this just has to be space. It doesn't have to be level. It just has to be space. I've mentioned the flared sides where the ramp is located within the pedestrian circulation path. The ramp needs to have flared sides. The flares are not part of the PAR though. Someone in a wheelchair would not come part way up the ramp and then turn across the flare. They want to do their turning on a level landing. So you might say then what's the purpose of the flares? The flares are there strictly for the safety of able-bodied. pedestrians. And the maximum grade is 10% measured parallel to the curb. If there was no flare, or if this flare was very steep, it would be a trip hazard, a potential trip hazard for able-bodied pedestrians. So keep that in mind. Kind of a minor point, but the flares are not part of the PAR. The flares are there for safety of able-bodied pedestrians.
Ron,
Yes.
sorry. We
You're
have
fine.
a little bit of an extension or a piggyback on the ODOT gutter at 8.3% cross slope question.
Okay.
So they're saying that 8.3% gutter cross slope exceeds the PAR running slope of 5%, doesn't it? Would the gutter need to be replaced on resurfacing projects due to that cross slope, or would it require a waiver?
That's a great question, and that's probably, again, I hate to kind of evade these questions, but I think the answer is going to be it depends. In resurfacing, if you could do it, I think it would be better, yeah, to correct that and make it 5%, the running slope for crossing the street. But I appreciate that given drainage and other things, you may not be able to do that. So in that case, it would be best to document that with a technical infeasibility. Good question.
Thank you, Ron.
What if the ramp is not in the pedestrian circulation path like you see here? Notice the ramp is in the grass strip. In that case, we can use vertical curb returns like you see here or here, although this is not a good example. It lacks detectable warning. But notice the ramp is in the grass strip. Pedestrians are not likely to walk across it, and so we can use vertical curb returns. But I would caution, be careful in doing that. Where the ramp is in the pedestrian circulation path, you need flared sides. I was traveling during the holidays, and this is a photograph I took. This is sort of how not to do it. It looks like a newish ramp. It doesn't have detectable warnings, but notice these, to me, these concrete sections here are areas where pedestrians could walk and actually are likely to walk. And these vertical curb returns here are a trip hazard for pedestrians. Personally, I think if this was my project, I wouldn't have put the concrete here or here. I would have made this a grass strip. Or if you're going to leave it concrete, then we need to have flared sides there too, so it's not a trip hazard for pedestrians. But my concern is, notice everything is kind of that light gray concrete color, and especially older pedestrians or pedestrians with low vision, they can't distinguish those subtle changes in shades of gray. It just looks to them like a walkway, and they'll get tripped up by those vertical curbs. So again, this is more a safety issue than an accessibility issue. Drainage, you saw this in the video. It is a continuing challenge. Many communities where I visit for training, you do see ramps with water at the base, or at this time of year, and that may freeze and become ice and then be a slip and fall issue for pedestrians. Of course, the textbook solution is put the inlets upstream of the ramps, but I appreciate in reality we can't always do that, but we should try to pay attention to drainage. And then surfaces. Again, it's too bad we can't, we're not all together and we can't go out and kind of demonstrate this, but this is not a requirement. It's a best practice, but curb ramp surfaces should be smooth. Texture makes them hard to climb. So both of these ramps comply with PROAG. Again, I'll repeat, both of these ramps comply with PROAG. The better design is the one on the right. Notice the ramp and the landing are smooth. The one on the left here, I realize this looks great, but climbing that textured, that block or paver surface there in a manual wheelchair is going to take more energy to climb, and to try to turn on a textured surface also is more difficult. So any questions on any of that we've covered so far? Actually, did we have a question, Karen?
We do. We had one pop in right when you asked that. It's
Okay,
perfect timing. This person asked for a federally funded project if we need a 1-by-1 land from a private property for an ADA curb ramp to make it ADA curb ramp. What should we do?
Could you repeat that again, please?
Yes. For a federally funded project, if we need a 1-foot by 1-foot land from a private property for an ADA compliant curb ramp to make it ADA compliant, what should we do?
Yeah, I'm not sure I understand the question. Is that 1-foot by 1-foot landing?
This person, yes, they said.
Well, that wouldn't really be wide enough to do any sort of turning on. I'm not sure how to answer that at this point. Whoever asked that, if you'd want to email me maybe a section of a drawing or a photo or something so I could get a better feel for what's going on, I'd be glad to offline give you a response to that if you'd want to do that.
Oh, wonderful. Thank you, Ron. I will go ahead. Yes, I will. I'm sure they got that message.
Okay, thanks.
Mm-hmm.
And Kara, how about, this is a little bit out of order, but since I planned on covering 2 videos today, this is probably a good break point. Why don't we show the second video, if you wouldn't mind, Kara? Our second video today. This video is a little bit out of order, but that's fine. This video is going to show low vision pedestrians and some of the challenges they face. I think it's pretty good video. The only thing I would note is they tend to suggest or show, and it may be a video capability thing, but they tend to suggest that the only low vision kind of characteristic is people have blurred vision, which is one type of low vision. But low vision could also be a very narrow field of view. It could also be a normal field of view, but maybe there's like the person just sees a big black spot in front of them, so their vision is limited in that way. So keep that in mind as you view the video. But why don't we do the second video on low vision pedestrians, Kara?
Sounds great, Ron. I've got it queued up. We'll go ahead and play it now.
Thanks, Kara. I'm going to stop it here. This really predates PROAG, so it's somewhat outdated. So let's go back to the slides.
Ron, we did have a question also while the video was playing. Do you mind if I ask it quick?
No, please.
Okay. This person said, should someone install detectable warnings at alleys?
Great question. And can I delay that till tomorrow? We will talk about that tomorrow. In fact, I have a specific example about an alley. So if you don't mind, I'll delay answering that till tomorrow.
Wonderful. Thank you, Ron.
So we've talked about the PAR and we've talked about the basics of curb ramps. Now what I'd like to talk about is the types of sidewalk to street connections, and there's actually 3 of them. There's 2 types of curb ramps. There's perpendicular and parallel curb ramps, and then something called the blended transition. And we'll now talk about each of these in more detail. So perpendicular ramps, you have 2 ramps per corner, like you see here. my pointer. Of course, the max grade is 8.3%. Should be a minimum of 4 foot by 4 foot turning space at the top. And then if cross travel is permitted, like you see here, these ramps are in the pedestrian circulation path, they need to have flared sides. We talked about this. The ramp needs to intersect the curb at right angles so that both wheels of the wheelchair enter and leave the ramp at the same time. The ramp you see in the upper right, I should put a big red slash through that. This is what I call a skewed ramp. This is not, notice the ramp doesn't intersect the curb at right angles. And if you look at the photo, notice one of the wheels of the wheelchair, one of the small front wheels, is off the ground, which I keep emphasizing is not a desirable situation because it adversely affects the stability of a manual chair. Cross slope. We had questions about cross slope earlier. What about the perpendicular curb ramp cross slope? The final rule says the cross slope of a curb ramp run shall be 1 to 48 or 2.1% maximum, but there is an exception. At crosswalks, the cross slope of the curb ramp run shall be permitted to be equal to or less than the cross slope of the crosswalk as specified in section R302.5. So what does R302.5 say? And you'll notice the cross slope requirements are a function of the traffic control on the approach, the intersection approach that's involved. So if the approach is stop or yield controlled, the maximum cross slope is 2.1%. If it's an uncontrolled approach, meaning no stop sign, no traffic signal, 5% max. If it's the approach is controlled by a traffic signal or a pedestrian hybrid beacon, 5% max. And if it's a mid-block crosswalk or crosswalk at a roundabout, the cross slope shall not exceed the street grade. So those are the cross slope requirements for perpendicular ramps. I hope that addresses the question I think someone had earlier about cross slopes at intersections or at crosswalks. Here we see a set of perpendicular ramps at a corner. I'd point out several things. Notice on this side of the ramp in the lower left, this is the buffer strip or tree lawn or whatever we want to call it. So it's not a pedestrian circulation path. So we have a vertical curb return, likewise up here. Level landing that serves the two ramps. It's a smooth surface. I like that. What I don't like about the ramp, and this ramp looks like it's PROAG compliant. So I mean, it complies with PROAG. But recall a few minutes ago, I said it's better to have a smooth surface ramp than a textured ramp. It's easier to climb for someone in a manual chair. So I think if this was my project, I'd probably make the ramp smooth, and maybe you can make the flare brick or even this area brick, because I don't think we're going to have folks with mobility impairments really walking in this area. So I think you could still have the color, but to me it's important to have the ramp, the color and the texture, but it's important to have that ramp be smooth.
Ron, we have
Yeah.
another question.
Okay.
The question actually looks like we just have two. First question, why is the cross slope threshold at an uncontrolled intersection twice the amount of a controlled one?
Because with the uncontrolled or signalized, traffic may be going through there at a higher speed, whereas at a stop or yield control, traffic will be moving at a slower speed at the actual, as they go through the intersection.
Okay, thank you. We have two more questions as of right now. Next question, if I have an intersection with a slope of 15%, would I be required to completely redo the intersection, or document with technical infeasibility?
Yeah, good question. It's going to depend on what sort of maybe project you have going on there. But I would say it sounds like it's an area where technical infeasibility may apply. And so I would document that. And yeah, I don't have it in this presentation. I use it in some other ones, but a few years ago, I attended an access board webinar, and I have a drawing. It shows, I think, going from the level landing to a street with a grade of 14%. And it shows how they transitioned that change. And I've used that in some of my presentations, and I've had people tell me that their agency would not allow that according to their criteria. And so I guess the point I'm trying to make is this is kind of a gray area. There is no, I think, universally established kind of solution or criteria for that situation. I think we probably need some more research and maybe just experience with mobility impaired individuals traversing some of these transitions to see how well or not so well they work. So yeah, to me, the bottom line would be to make it accessible to the extent practicable to do so, and then document that technical infeasibility.
Okay, thank you. Um, yeah, I think there was a little bit of a follow-up to that. Um, they said, wouldn't you want the cross slope to be lower at an uncontrolled intersection because traffic is moving faster? Um, Basically, you wouldn't want the person in the wheelchair to be going into the intersection twice as fast as the controlled intersection.
Well, these are the traffic speeds. These would be the motor vehicle traffic speeds. And so to get a 2.1% max would take more of a variation or disruption of the grade line of the roadway. And so at higher speed roadways, you want less disruption, which is why you would have a 5% maximum as opposed to 2.1%. 2.1% might create a kind of an abrupt change in the roadway gradient or line.
Okay. Next question. They keep
Okay.
coming. Oh, she says that makes sense. They're the cross slopes of on the roadway, not the ramp. So
That's correct.
that
Yeah.
okay. Yep. Next question. Can you use R302.5 as a reason why the cross slopes exceeds 2.1% at a roundabout, or does the agency have to adopt PROAG?
Well, adoption is really up to the agencies. I mean, I'm a fan. I think agencies should adopt PROAG, but regardless of whether you adopt it or not, remember what I talked about yesterday, the legal obligation of a public agency, whether it's a state DOT or a county or a municipality or a village or whatever, is their facilities have to be accessible to and usable by individuals with disabilities. And probably the best guidance to do that or demonstrate that you're doing that is to comply with PROAG. But what was the first part of the question again?
Can you use R302.5 as a reason why the cross slopes exceed 2.1% at a roundabout?
I would say yes.
Okay, thank you. And one last question. Well,
Okay.
it's a two-parter, but it's a short one. This person asks, is there a technical infeasibility form? And if so, where can they find that?
Another great question. And actually, the Access Board doesn't have one. A number of agencies have what I'd call templates to do that, to document a technical infeasibility. And I I've not done it recently. It's been a couple years, but I think if you just Google like PROAG technical infeasibility templates or examples of technical infeasibility templates, I think you'll find a lot of links that come up. There's a number, pretty much, I think all the state DOTs probably have technical infeasibility templates, and also an increasing number of local agencies do. So you can, depending what you find, find one that seems to suit your needs better than others. You can model your template after those. But in fact, you pick the best of several templates and make your own template. There is no kind of designated or standard template. It's up to the option and the wishes of the agency.
Okay. Well, thank you, Ron. That is all the questions we have for now.
Okay, thanks for those good questions.
Mm-hmm.
So let's see, we're talking about advantages and disadvantages of perpendicular ramps. I think we've talked about most of these already. Second type of ramp, curb ramp, is the parallel curb ramp. And notice here, the sidewalk ramps down and the landing is below the sidewalk. Also notice this is the only curb ramp design where the detectable warning is part of the landing. And notice here at the back of the sidewalk, they have this little curb or retaining wall. As I indicated, that's optional under PROAG. There's no requirement, but I think that's a good practice because I think it helps reduce maintenance, prevents material from washing onto the sidewalk. Minimum 4 foot by 4 foot turning space at the bottom. Because this curb here makes this a constrained landing, the best practice would be to make this 5 feet from back of curb to the curb here. But again, the requirement is 4 by 4 is the minimum. Here's another kind of drawing version of the same thing. What about parallel curb ramp cross slope? The final rule says the cross slope of the curb ramp run shall be 2.1% maximum. Main advantage of the parallel curb ramps is that they fit within narrow right-of-way. To me, the main disadvantage is because that bottom landing or turning space there, because of where it is, water and debris and sediment often accumulate there. So it is a maintenance issue to keep that area clear of sediment and debris. That, to me personally, that's the main disadvantage of the parallel curb ramp. So those are the two types of curb ramps. The third type of sidewalk to street transition is what's called the blended transition. And here you see an example. Notice the sidewalk is missing around the entire corner, and so we need detectable warning surface here. So that's a blended transition. The other thing about a blended transition is the maximum grade is 5%, not 8.3%. Here we see another blended transition. Here on the far right, this is, I think this is like a courthouse or something like that. So this is sort of a governmental plaza. But the key thing is this, and you can see it's kind of brick and some concrete sidewalk here. But the key thing about it is this plaza is at street level. And so without warnings, a blind pedestrian could reach the street without realizing it because there's no curb. So notice the use of the detectable warning surfaces here, warning the pedestrians they're about to enter the street. Here you see in the lower left another blended transition, kind of a schematic of maybe what I just showed. This is a brick plaza. This is not a curb, it's just a strip of concrete. So the street and the brick street and the brick plaza are the same elevation. Nothing to let the pedestrian know they're about to enter the street. On the right here, you see what I would call an improved design of that situation. Notice they have ground-mounted planters here to kind of force the pedestrians to the apex of the corner, and then they have detectable warning surfaces. And one of the main disadvantages of blended transitions, as the slide says, and maybe you can see it here, is because so much of the curb is missing, sometimes motorists will mistake this for a driveway or for a side road, and so may actually encroach on the sidewalk. And so you'll notice here, they have this a bollard here. That's an attempt to keep motor vehicles out of that area if the driver mistakes it for a side road or a driveway. But of course, bollards are a fixed object hazard for bicyclists and can cause harm to bicyclists. So again, it's kind of a matter of we have to balance among all users and provide an accessible and also safe facility. So those are the three types of sidewalk to street transitions, two types of curb ramps and blended transition. Notice I have not mentioned the single diagonal ramp, and that's because, as I've highlighted in red here, under PROAG, we should no longer be building single diagonal ramps. They may be okay in alterations if it's technically infeasible to use one of the other three types of sidewalk to street transitions, but we should not be building any more new single diagonal ramps. And you can see curb ramps need to land within the crosswalk that they serve, and diagonal ramps don't do that, and so are not permitted. And I think you saw this something similar to this in the video. This is not a screen grab from the video, but it could be. Notice this individual in the wheelchair here has crossed the street in the crosswalk, but to get to this single diagonal ramp, he has to leave the protection of the crosswalk. And notice traffic is to his back where he can't keep an eye on it. And I think Dennis used the term, I think, very disconcerting for that situation, which it is very disconcerting. And so this is probably the main reason we should no longer be building single diagonal ramps. The other type of ramp, and then I think we'll stop here, that exists, but it's kind of, as the name implies, it's a combination of other two ramps. Notice here, the sidewalk ramps down to a level landing. Here it ramps down to the sidewalk, and then we have the curb ramp, and same thing over here. This is called a combination ramp. Notice both of these are from the Phoenix, Arizona area, so unlike the eastern or midwestern US, they don't have grass lawns. I guess they call that desert landscaping. Looks like lava rock. So here, this is not a pedestrian circulation path, so you can use the vertical curb returns. Likewise, here on the far right, landscaping, so can use a vertical curb return. But on this side of the ramp, we have the pedestrian circulation path, so we need to use flares. That looks like steeper than 10% personally, but it looks like the reason is there's some sort of utility there apparently. It looks like a utility cover, and so hopefully there's a technical infeasibility right up there explaining that steeper flare. But that's not a really big concern to me, because remember, that's not part of the pedestrian access route. This is here for the safety. That flare is there for the safety of able-bodied pedestrians. And one concern with steep flares is what happens if you get snow and ice on that flare, like Columbus or Morgantown or Cleveland. But here in Phoenix, probably don't often get snow and ice on that flare, so that's probably not a real big concern given this specific context. So I think we're about at the closing time, and this is a good place to stop, Kara. I think we'll stop here. Tomorrow, we'll look at some curb ramp examples. We'll look at detectable warning surfaces, and then we'll cover a variety of other topics in kind of less detail. So thanks everybody for participating. Thanks for your great questions. Hope you have a great rest of the day, and we'll see you tomorrow. Kara, I'll turn it back to you for closing comments.
Great. Thank you so much, Ron. Okay. Well, a big thank you to Ron Eck for his time and knowledge, and thank you to all of you for participating. Just a reminder, the recording and handouts will be headed to your inbox shortly. If you were present and logged in for the full duration of the webinar, you will receive a certificate of attendance within 5 business days. As we close out, a brief survey will appear on your screen. We'd be so grateful if you'd take a moment to fill that out. We look forward to seeing you all back here for part 3. Thanks for joining us and have a wonderful afternoon.